as we continue exploring the fascinating intersection of artificial intelligence, cutting edge computing technologies, and the ethical frameworks that guide their responsible implementations. It gives me immense pleasure to introduce today's distinguished speaker, Dr. P. Subhashri Ma'am, Adjunct Faculty, Department of Computer Science, Alagappa University, Karaikudi, Tamil Nadu. Dr. Subhashri Ma'am is a renowned academic and research with vast experience in artificial intelligence and data analytics and computing systems. Her insights and expertise have inspired many scholars and practitioners in the field. We are privileged to have her share her knowledge with us today. I am sure her session will provide us with valuable perspectives on integrating smart and ethical approaches in system design, a key aspect of building the future of intelligent computing. On behalf of the Ionizing Committee, I extend my heartfelt thanks to Dr. Subhashri Ma'am for accepting our invitation and to all the participants for your enthusiastic involvement. Let us look forward to an engaging and enlightening session ahead. Once again, welcome everyone and thank you for being part of this program. Now, let's warmly welcome Dr. P. Subhashri Ma'am to lead us through today's session. Welcome, ma'am.
Yeah. Thank you, Gayatri.
Thank you.
Good evening, everyone. I'm Dr. P. Shubhastri, currently serving as a teaching assistant in the Department of Computer Science, Alagappa University, Karaikudi. I hold a PhD in Computer Science from Alagappa University with the specialization of medical content security, cryptography, and network security with image processing. With over 8 years of academic and research experience, I have contributed to both teaching and research in some emerging areas like cloud computing, AI-driven healthcare, and intelligent systems. And I have published 21 research papers, including 13 in Scopus, and recently filed a patent entitled Companion App with Generalized API and Degeneralized Data Source using Signaler Architecture. Today, I'm delighted to share insights on a fascinating and fast evolving theme, convergence of AI, IoT, and edge computing, building smarter systems. This convergence is redefining how actually the machines, data, and intelligence come together to create real-time, efficient, and adaptive environments from smart healthcare to smart cities. I'm truly honored to be part of this FDP program, and I look forward to an engaging session filled with ideas, discussions, and learning from all of you. So basically, the relationship between the AI, IoT, and edge computing is the main thing. To begin, let us understand what we mean by convergence. Artificial intelligence, AI, provides the intelligence, the capability to learn, predict, and decide. And IoT brings the connectivity, which means the linking billions of physical devices and sensors. And edge computing, it delivers the proximity, like it enables the computation close to the data source. So when these three domains integrate, AI, IoT, and edge computing, our systems become faster, more autonomous, and responsive. That is the main thing. Here we have a simple example. An industrial IoT setup using edge computing can analyze sensor data in real time using AI models, and it deployed locally, reducing latency and dependency on cloud infrastructure. So this convergence marks the foundation of Industry 4.0 and the emerging era of intelligent automation. So why combining these technologies like AI, IoT, and edge computing is necessary? It's necessary Because the motivation of integrating the AI, IoT, and edge computing arises from the limitations of each when used independently. IoT generates massive data but lacks analytical capability, and AI requires data to learn, but it depends on computational infrastructure. Edge computing offers localized processing but benefits from intelligent decision making. So, only by combining them, we achieve a system that can collect, analyze, and act all within milliseconds. So that is the main factor. So, this integration addresses issues like latency, bandwidth consumption, and data privacy while enabling continuous intelligence, a system that learns and adapts dynamically in real time. We already know what is meant by the artificial intelligence. AI basically refers to the simulation of human intelligence in machines that are programmed to mimic and perform tasks that would typically require human intelligence. So, in the AI contribution within the convergence, it serves as the brain of the system. That is the main thing. So it enables the prediction, classification, and autonomous decision making based on IoT data. With machine learning and deep learning algorithms, AI actually converts the raw sensor data into actionable insights. At the edge, lightweight AI models can detect anomalies, optimize energy usage, or identify faults before they escalate. As faculty members, it's important. Um, uh, we actually emphasize AI's role in transforming data-driven systems into self-learning ecosystems and capable of adapting without explicit programming. So in IoT, it refers to the network or interconnected physical devices embedded with sensors, software, and other technologies that enabled them to collect and exchange data over the internet. Uh, so the Internet of Things forms the physical layer of our intelligent ecosystem. Though the sensors and the communication networks, IoT devices actually continuously collects environmental data like temperature, motion, health metrics, or industrial parameters. This data becomes the fuel of AI analytics, fuel for AI analytics. So when we connected with edge computing, IoT devices can perform pre-processing, filtering, and even basic inference locally before sending relevant information to the cloud. Thus, the IoT is not merely about connectivity, but about enabling seamless interaction between the physical and digital worlds. So, in the benefits of AI-enabled IoT, actually, here we have 10 benefits: the real-time data analysis, predictive maintenance, enhanced automation, improved customer experience, enhanced safety and security, energy efficiency, smart decision making, healthcare advancement, traffic optimization, and resource optimization. So now we discuss the highlights. Why edge computing is critical in real-time systems? Because that is the role of the edge computing. In edge computing, it brings computation closer to the source of data, reducing the dependency on centralized cloud systems. So in traditional IoT architectures, data travels to remote servers for processing, causing latency and bandwidth overhead. By processing data at the edge, we achieve real-time responsiveness, improved security, and reduced transmission costs. Generally, edge devices can run AI models locally, and it enabling the immediate decision making. For instance, detecting faults in manufacturing equipment without waiting for the cloud feedback. This distributed intelligence paradigm represents a shift from cloud only to cloud plus edge ecosystems. So now we have to see how AI, IoT, and edge complement each other. So the synergy among these three technologies, AI, IoT, and edge computing, is what creates truly smart systems. That is the main thing. IoT provides continuous streams of data. Edge computing processes the data near its source for the real-time insights. And AI enhances this process by introducing adaptive intelligence. So, with the usage of the adaptive intelligence, the AI allowing systems to learn from patterns and improve over time. Together, the AI, IoT, and edge computing, they create a feedback loop, like sensing, processing, learning, and acting. And this loop forms the essence of next generation systems, from autonomous vehicles to predictive healthcare solutions. So, in the evaluation of intelligent systems, the role of IoT in AI, it traces how systems evolved toward convergence. The evaluation of intelligent systems can be viewed in stages. Initially, we had an isolated embedded systems performing predefined tasks. Then came the IoT, Internet of Things, and it enables connected devices with the usage of sensors. And subsequently, cloud computing allowed a large scale analytics, but latency remained an issue. So, with the advent of AI and edge computing, we are moving towards systems that are distributed, adaptive, and context aware. Understanding this progression, how the AI, IoT, and the edge systems evolve toward governance, helps us appreciate how far technology has come and where it is headed. So, in the role of IoT in AI, scalability and flexibility, edge computing, sensor integration, data secure, even security and privacy, data acquisition, data variety and volume, data pre-processing, real-time decision making, distributed computing, adaptive learning, contextual understanding, and feedback loops are there. So, in the architecture of convergence systems, a typical converged system consists of multiple layers actually, like a device layer, edge layer, and a cloud layer with application layer. In device layer, the basic things like sensors, actuators, and IoT nodes, which are helps to gather the data. These are all in the device layer. And in the edge layer, the local processing units performing filtering, inference, and control. And in the cloud layer, the centralized analytics like data storage and model training are here in the cloud layer. And in the application layer, the user facing systems, and it provides decision support or automation. uh, Such a layered approach only ensures the scalability and flexibility, and it is also allows tasks to be optimally distributed between the edge and the cloud depending on latency and resource needs. In the benefits of convergence, the convergence of AI, IoT, and edge computing actually delivers multiple benefits. It reduces the latency, because the decisions are made locally and instantly. So the latency was completely reduced, and it improved the reliability. The systems can function even without the constant cloud connectivity, and it enhanced the data privacy, because the sensitive data can be processed at the edge. So the uh, privacy is concerned here, and the scalability, distributed processing prevents network congestion and the energy deficiency. Smart systems can optimize resource, which resources are used dynamically. So these advantages have made this convergence uh, the cornerstone of digital transformation in industries and the smart environments. So these are all the examples of AI and IoT, the robotic manufacturing, self-driving cars, retail analytics, smart thermostat solutions, smart home, automated vacuum cleaners, healthcare, and wearable devices. Um, the the convergence of these technologies is not confined to theoretical models only. It is transforming entire industries. For example, in healthcare industry, the wearable IoT devices collect patient vitals and AI algorithms are used to interpret the data, and edge nodes ensure instant alerts for emergencies. In agriculture, sensor networks and edge analytics optimize irrigation, and soil health monitoring is also there. So these are all the real world applications in AI, IoT, and edge convergence. In manufacturing, the predictive maintenance system prevent machinery failures using AI models deployed at the edge. And in smart cities, it utilizes this trade for traffic control. What are all the trade means? The AI, IoT, and edge computing. In smart cities, it uses the trade for traffic control, energy optimization, and waste management. Each of these applications highlights how localized intelligence and connectivity create sustainable, efficient, and safe environments. In smart healthcare systems, mm, now we all are known devices such as wearable fitness trackers, ECG monitors, and smart patches continuously generate real-time physiological data. Traditionally, this data was sent to cloud servers for analysis, but now we are using the edge computing. It allows the immediate processing near the patient. So the artificial intelligence models actually detects the anomalies such as sudden oxygen level drops and alert healthcare professionals instantly. This in the smart healthcare system, the IoT with AI-driven analytics at the edge reduces the minimizes the critical response time and enhances the patient safety. Additionally, by processing sensitive health data locally, we address major privacy and security concerns. These are all the key factor in medical applications. So, in smart cities and transportation, smart city initiatives heavily depend on the synergy of AI, IoT, and edge computing. The connected sensors manage lighting, waste disposal, and energy consumption efficiently. In transportation, the edge-enabled cameras and sensors are there to gather the traffic data, and AI algorithms predict congestion patterns or detect violations in real time. This model fosters sustainability, improves mobility, and enhances the quality of our life. Um, so these are all the key outcomes for modern urban governance. So the AI, IoT, and edge computing, these technologies have the potential to revolutionize numerous industries and aspects of our daily lives. In industrial automation and industry 4.0, it is a paradigm shift where factories evolve into smart interconnected ecosystems. So in IoT sensors, it actually tracks operational parameters, while AI powered analytics to identify inefficiencies or potential breakdowns. This integration enables predictive maintenance, reduces the downtime, and enhances the product quality. In smart agriculture and environment monitoring, um, agriculture today, it relies on data driven decision making. Some IoT sensors are used to measure the soil moisture, humidity, and even though the nutrient content also measured by the sensors. Edge nodes analyze this data and it locally to decide irrigation schedules. While AI models predict crop diseases or yield, this approach minimizes water and fertilizer wastage, and it enhances the sustainability. So with the usage of this three AI, IoT, and edge computing, it improves the automation and decision making, and it enhances the connectivity and interoperability, and it personalized the experience and services. Privacy and the security challenges are there, and ethical and societal implications are also is the part of this three combinations. And in edge computing, it is important to distinguish between cloud, fog, and edge computing. In cloud computing, it provides a centralized resources for storage and large scale model training. So in fog computing, in cloud computing, it is an infrastructure and a software system that allows for access a shared network of storage, server, and application over the internet. With cloud computing, the users can access database resources via the internet from anywhere for as long as they need without worrying about any maintenance and management of actual resources. So in fog computing, it acts as an intermediary, distributing computation between the cloud and devices. And in edge computing, it actually performs the computational directly at or near the data source. So this layered approach optimizes system efficiency. While AI model training may occur in the cloud, the real-time inferences is often executed at the edge or fog layer to reduce latency and bandwidth costs. So in cloud computing, it has some limitations. So only we are moving to the edge computing. In cloud computing, the latency, bandwidth, availability, energy are the some limitations. And in edge computing, it is a distributed information technology architecture in which client data is processed at the periphery of the network as close to the originating source as possible. So in a typical data flow pipeline, IoT devices first collect the raw sensor data. This data actually undergoes pre-processing at the stage. So whenever we have collect some data on the net or any platform, the pre-processing is the first stage to process the filtering, noise removal, and feature extraction processes. So the raw sensor data is processed by using the pre-processing techniques, and the next the AI inference takes place at the edge or fog level, it producing immediate results. The processed summarize or model updates are then transmitted to the cloud for deeper analytics and retraining. This hierarchical structure ensures that only meaningful data travels upward, conserving bandwidth while ensuring timely insights for critical operations. So why the need for edge computing? The edge computing powers the next industrial revolution, transforming manufacturing and services. It optimizes data capture and analysis at the edge to create actionable business intelligence. It creates a flexible, scalable, secure, and more automated technology systems and core business process environment. And it developed due to the exponential growth of IoT devices, which connect to the internet for managing transformation over cloud. Edge computing promotes an agile business ecosystem that is more sufficient. It performs faster comparatively with the previous methods, and it saves costs, and it is easier to manage and maintain. So at the point of security and privacy considerations, systems become more connected. The security and privacy gain paramount importance. So IoT devices actually often the weakest link, susceptible to attacks or data breaches. Edge computing mitigates some risks by processing sensitive data locally, but secure protocols and encryption remain essential for edge computing. AI can enhance cybersecurity by detecting abnormal patterns, intrusion attempts, or data tampering in real time. In the edge devices challenges in integration, despite its promise, Convergent faces several challenges too, like interoperability, operability issues. The device and systems from multiple vendors may not communicate seamlessly. Resource constraints. The edge node have limited computational and energy capacities. Data management, handling heterogeneous high velocity data streams require sophisticated architectures. And in the one of the foremost challenges in AI IoT system is scalability. As the number of connected devices, for example, the edge devices, uh, the number of connected devices increases, ensuring consistent performance, connectivity, and management becomes complex. So each device may use a different protocol or data format, leading to interoperability issue. The open standards such as COAP and OPC UA are emerging to address this difference. From an architectural standpoint, the modular design and standardized APIs enable smoother integration. The energy consumptions is the another critical factor in deploying large-scale intelligent systems because the IoT devices and edge nodes often operate on limited power resources sources. So the energy efficient computation and communication is very much needed. Basically, AI algorithms can optimize energy by use dynamically adjusting data transmission rates or computational loads. Moreover, green edge architectures. It incorporates renewable power sources and efficient cooling contribute to sustainability goals. So in the Internet of Things and edge computing, it focuses on the importance of real-time intelligence. So in many domains, such as autonomous driving or industrial automation, decisions must be made within milliseconds. This is where real-time analytics become indispensable with the usage of IoT edge computing. In the edge computing, real-time data processing is performed here. So edge computing facilitates instantaneous AI inference close to the data source. It enables the timely responses. For example, in autonomous vehicles, edge-based perception systems identify the obstacles immediately without waiting for cloud feedback. In integrating AI at the edge, it transforms systems from reactive to proactive. So in reactive to proactive, the capable of anticipating events rather than merely responding. It also ensures that deterministic latency and efficient model execution is key to achieving true real-time intelligence. In the architecture of edge computing, it actually explains how intelligence is distributed across multiple nodes. The distributed AI refers to the deployment of learning and inference across multiple edge and fog nodes. Instead of relying solely on centralized models, edge intelligence allows each node to process data locally and it collaborate with peers and update models incrementally. So this approach enhances the scalability, fault tolerance, and data privacy. Techniques such as federated learning enables the training across devices without sharing raw data, thereby preserving confidentiality. In the federated learning and data privacy, it is an innovative paradigm that trains AI models collaboratively across multiple devices while keeping data local. So each device computes model updates based on its own data and only share the parameters, not the raw data. it only shares the parameters within the central server. So in IoT and edge environments, the federated learning enables continuous improvements of models without compromising sensitive information. So how edge computing works? Um, the emergence of 5G technology, a network of micro data centers that store or process critical data locally and push received data to a centralized data center or repository of cloud storage. Actually, that is mean by the edge. In typically IoT use cases, a massive chunk of data goes through the data center, but edge computing processes the data locally by using the data pre-processing, and in the results, it reduces the traffic in the central repository. This progress are actually done by IoT devices. It transfers the data to the local device, which includes storage, compute, and network security. After that, the stored data is processed at the edge, while another portion is sent to the storage repository or central processing data center. So, in the role of 5G and next generation networks, it actually uh, provide the importance of 5G in enabling convergence. So the emergence of 5G technology is a crucial enabler for large scale AI IoT edge integration. With ultra low latency, high bandwidth, and massive device connectivity, 5G networks support real-time data, real-time data exchange, and high-speed AI inference at the edge. Moreover, the 5G enhances mobility management and edge orchestration. It ensures the seamless data flow. In the coordination between the edge and cloud components, the middleware is the main thing, and it plays a vital role in coordinating distributed resources from edge to cloud components, edge and cloud components. So, in the technologies like Kubernetes, OpenFog, and EdgeX, Foundry provide frameworks for containerized deployment and lifecycle management of AI services. Efficient middleware ensures the optimal resource usage and scalability while maintaining the system stability. In the data management and storage strategies in the edge computing, it also tells how edge computing works. It managing the vast amount of data generated by IoT networks is a non-trivial task. So at the edge computing, the transient data is processed and it was summarized to reduce transmission load. So the cloud stores historical and large scale data set for deeply analytics and model retraining. Hybrid storage strategies actually combined the time series databases, distributed file systems, and data leaks, and it ensures the efficient retrieval and processing. In the AI model for optimization for edge devices, it focuses on lightweight model deployment strategies, like deploying AI models on resource constrained edge devices requires optimization. So techniques like pruning, quantization, and knowledge distillation reduce the computational overhead while maintaining accuracy. The frameworks like TensorFlow Lite, PyTorch Mobile, it enables seamless deployment across various hardware platforms. Research in hardware software co-design is advancing with a specialized AI such as TPU and NPUs. Understanding this optimization technique like pruning, quantization, and knowledge distillation, it actually helps us to explore applied AI engineering, and it ensures the intelligence runs efficiently at that stage. So these are all some edge computing examples, CCTV systems. Um, in the edge computing, it has several advantages like speed. Comparatively, in cloud computing, it has uh, it is more speed, scalability, reliability, cost effectiveness, and security. And also it has some disadvantages, incomplete data, because edge computing only processes and analyze partial sets of information only. The rest of the data just discarded, so the incomplete data may be occur in edge computing. So it is the main disadvantage, and more storage space. um, Comparatively with cloud computing, edge computing needs more storage space, uh, because it take a considerably higher storage, because it holds all the informations. And in applications, yeah, smart manufacturing plant is the main case study of the AI, IoT, and edge technologies. Let us consider a smart manufacturing plant as a case study. In that smart manufacturing plant, the IoT sensors monitoring the vibration, temperature, and the load parameters on industrial machines. The edge servers perform real-time anomaly detection using AI models trained on historical failure patterns. If an abnormal vibration pattern is detected by the sensor, the system automatically triggers maintenance, uh, maintenance alerts, um, and it's preventing the downtime. Meanwhile, the data summaries are sent to the cloud for deeper trend analysis. This smart manufacturing plant setup illustrates how convergence enhances the operational efficiency, predictive maintenance, and the cost savings. These are all the core goals of Industry 4.0. And then another use case is farming, smart agriculture network. In the farming, um, where IoT, AI, and edge computing combine to enhance the productivity and sustainability. So basically, IoT in smart farming, IoT based soil sensors measures moisture, nutrient content, and environmental parameters like the soil, whether the plant is needed for water or something else. So the edge gateways perform local analysis to determine irrigation needs and send real-time instructions to actuators. The AI models trains on weather and crop data predict optimal watering and fertilization schedules, because the sensors already monitor the soil status. So the AI models trained on weather and crop data. This integration reduces the resource wastage like fertilizer, water, and it also improves the yield quality, and it supports precision farming. For rural and developing regions, such systems hold immense promising in addressing agricultural inefficiencies through intelligence automation. The third main application of the edge computing, these three technologies, AI, IoT, and edge computing, is healthcare. So in the healthcare, wearable sensors track patients' vitals continuously, such as heart rate, oxygen saturation, or glucose levels. Edge processes analyzes the data locally to detect any abnormalities are there in the patient. So the AI-based predictive models identify early signs of illness or alerting physicians proactively. So this is not only enhances the patient care, but it also reduces the hospital load and operational costs. The privacy is maintained as most sensitive data remains on local devices. Such healthcare systems are foundational to future digital medicine and telehealth ecosystems. The next example of this three technologies is um, the convergence of AI, IoT, and edge computing is driving significant research worldwide. Key areas includes distributed learning algorithms, energy-aware edge architectures, AI model compression, and autonomous decision frameworks. There is growing emphasis on context-aware computing, where systems adapt to real-time environmental and user conditions. So the cross-disciplinary collaboration is essential. Combining this expertise in electronics, data science, networking, and embedded systems. Mm, so these are all the emerging research directions for researchers. The next thing is the emerging technologies supporting convergence. Several emerging technologies are reinforcing the AI IoT edge ecosystem. The blockchain is the main technology. It ensures secure and tamper-proof data sharing among distributed nodes. The digital twins is also one of the convergence technology, which create real-time virtual replicas of physical systems, and it enabling simulation and optimization. The quantum computing is a promising convergence solution, exponential acceleration in AI model training and optimization. Meanwhile, the 6G networks are projected to support even higher connectivity and intelligent systems. These technologies collectively shape next wave of intelligent autonomous systems, pushing the boundaries of what's possible in smart environments. The next example is next we have to know the role of cloud in converged ecosystem. While edge computing provides real-time intelligence, the cloud remains an indispensable component. It actually offers centralized storage, large-scale data analytics, and model training capabilities that edge devices cannot match. In a balanced architecture, the cloud handles long-term learning and orchestration, while the edge executes time and critical operations. This hybrid model, like IaaS, IoT, and edge computing, it ensures the continuous system improvement and global visibility. So, the assessing the effectiveness of converged systems, it also has some evaluation metrics like latency, throughput, accuracy of AI inference, energy efficiency, and security robustness. The simulation tools and the real world test beds can be used to evaluate the performance under diverse workloads. The continuous benchmarking allows iterative optimization. It ensures that the system meets both functional and non-functional requirements. Some of the future directions and innovations are there in convergence research. Um, we can expect increased autonomy at the edge, where devices not only infer but also learn locally. And AI-driven orchestration, it will enable dynamic task allocation across cloud, fog, and edge layers. And in advances in neuromorphic computing and tiny ML, it will make edge AI faster and more energy efficient. Furthermore, the integration of ethical AI frameworks, it may be ensure responsible innovation. So this trajectory underscores that the convergence of AI, IoT, and edge computing is not a transient trend. It represents the technological backbone of our future society. So, um, In the conclusion, the edge computing is very promising and has found many useful applications. Now we have to summarize the key insights from the from this three technologies. The AI provides intelligence, IoT provides connectivity, and edge computing provides proximity. So their convergence enables real-time, autonomous, and data-driven decision systems. Applications like healthcare, manufacturing, smart cities, agriculture, and beyond. Key challenges include scalability, interoperability, operability, privacy, and energy efficiency. The emerging technologies like 5G, blockchain, and federated learning further enhance this ecosystem. So, the understanding and integrating these domains equips us to build the smart, adaptive systems of tomorrow. In conclusion, um, bringing computation to the network's edge, it minimizes the amount of long distance communication that has to happen between a client and a server. The convergence of AI, IoT, and edge computing marks a pivotal transformation in modern computing. It embodies the shift from centralized intelligence to distributed context-aware decision-making systems. For academia, this convergence opens new avenues for interdisciplinary research, curriculum enhancement, and industrial collaboration. As a faculty, our role is to guide learners and innovators in harnessing these technologies responsibly for societal benefit.
Thank you, ma'am. Does anyone have about any queries?
Thank you. Any queries? Feel free to ask me.
Thank you, ma'am.
Queries are welcome.
Does anyone have queries? Okay, ma'am. Ma'am, may I conclude the session, ma'am?
Yeah, before concluding, I would like to take a moment to express my heartfelt gratitude.
Yeah, ma'am. Sure.
Okay, first and foremost, I thank the organizing committee for inviting me to serve as a resource person for this faculty development program. My special thanks to my classmate and my dear friend, Dr. Satish Kumar, for this warm opportunity and for organizing such a well coordinated event. To all the participants, thank you for your active involvement uh, and enthusiasm throughout the session. It was truly a pleasure to um, uh, interact and discuss with such an energetic group of academicians. I hope this session gave you useful insights into how AI, IoT, and edge computing can converge to create smarter real-time systems. So, wishing you all continued success in your academic and research journeys. Thank you, one and all. Thank you.
Thank you, ma'am.
Excuse me, ma'am. One doubt, ma'am.
Yeah, yes, please, ma'am.
Yeah, so integrating the IoT devices and the AI in smarter transportation system, do you know any AI tools or any applications, apps are there? Do you know anything? Hello?
Yes, ma'am. Yes, ma'am. So, um, I think the TensorFlow is one of the AI
Tool,
deployment framework. TensorFlow Lite.
spelling,
So
ma'am?
TENSORFLOW.
Okay.
I think it is the combination of IoT and AI convergence to predict the
Okay.
maintenance image recognition on edge nodes. And um, the in edge IoT platform, we all are known the AWS, ma'am. AWS IoT Greengrass.
Okay, ma'am.
And some software peoples are used in Microsoft Azure.
Azure.
Yes, Microsoft Azure is one of the AI and IoT device tools.
Okay. So, particularly in transportation system, do you know any tools, ma'am? Smart
Um,
transportation system.
Maybe smart transportation system. Mm, I don't know exactly, but
Okay.
POSH, BOSCH, POSH. It may be the industry.
POSH.
Yes, ma'am. It is one of the industry specific platforms.
Uh,
So it may be the edge analytics for connected devices. I think so.
okay, ma'am. Okay, thank you, ma'am.
Thank you, ma'am.
Yeah, thank you so much.
Yeah, ma'am. May I conclude the session, ma'am?
Yes, please, please.
Yeah, okay. Thank you. Thank you for all the participants. Thank you, Dr. Subhashri, ma'am. Thank you all.
Uh, Excuse me, ma'am. Attendance sheet or feedback link we didn't receive yesterday, ma'am. So any other thing is there for attendance and feedback?
Ma'am, today I'm surely sending the group, ma'am.
Yesterday I didn't receive, ma'am. That's why.
Okay, ma'am. Today I will send you.
Okay, it's not issue, no?
No, ma'am. No, ma'am.
Yeah. Okay, ma'am. Thank you.
Ah, okay. Okay. Thank you, ma'am.
Thank you.